Hello everyone, welcome back. So this time we're going over another problem with efficiency. Now, whenever we do a problem with efficiency, it's going to hit on power, it's going to hit on energy, and it's going to hit on quite a few different things. So this is a kind of a doozy here. Be afraid. Or don't. Okay, I'm stupid at times. I'm your professor. I can be. I'm a professor, you have to respect me. Okay, so continuing forward. Having fun here. So a 5 horsepower, 75% efficient motor is used to raise a container 10 meters into the air. Assume the container is full of bromine, and specific gravity of bromine is 3.12. The container has a mass of 500 kilograms. Okay, so wow, they're really putting a whole bunch of trouble on us here. We need to put specific gravity. That's no fun. Who wants to do that? But we have to. We have to use it somehow, I'm guessing. Or do we? Okay, so first off, 5 horsepower motor, 75% efficient motor. Let's work with that. So remember that power out is equal to the efficiency times the power in. So it's going to be equal to 5 horsepower times 0.75. And using my excellent math skills, thank goodness they can't see this pop up on the screen. As a note, I know that you can actually see that. Okay, it is 3.75 horsepower. Now, this is great. It works. But 3.75 horsepower? What is that? Well, we're going to convert it. So let's go ahead and get it done with. So 3.75 horsepower. Well, the first thing is that there are 550 horsepower and wrong direction. 1 horsepower and 550 foot-pounds per second. Okay, so we take care of that. That gets rid of horsepower. But foot-pounds, we probably want in joules because everything else is in kilograms and meters. It's all nice. Maybe you don't remember this, but what we learned a while ago is that 1 joule is 0.7375 foot-pounds. I want to ignore the whole per second thing because I don't need to change that. So foot-pounds will cancel, and 17.5 seconds. What happens when your calculator or your pen accidentally does something different than it's supposed to? So let's plug all this in. So 3.75 times 550 divided by 0.7375. Oh man, every single time. 3.75 times 550. 3.75 times 550. Oh, I caught myself this time. Divided by 0.7375. Checking it? Good. Okay, so this will be 2,796 watts. Quite a bit of power. So that's what's actually making it to do work. Okay, now it gave us the specific gravity, and it gave us mass, and it gave us the height. And just so you know, specific gravity, it's actually not needed. Because for one, we don't have a volume. We can't actually use that for anything. We can determine a volume. It's actually completely fine to determine a volume. But you're given the mass of the container. Wait. Yes, you're given the mass of the container. So we're assuming that that mass of the container is including the bromine. So with that, we're going to use our second equation we use all the time, which is power is equal to energy over time. And energy in this case would be potential energy because we're lifting stuff. So equal to mass, gravity, height over time. And we want to solve for time. So therefore, time would be equal to mass, gravity, height over power. Okay, so I'm going to erase all this stuff over here. Don't worry, I'll show you a page after this where it has it all written down. So if you didn't do it yet, for one, it's a video. You can go back and watch it. And 2, I'll be there for you at the end. Okay, so time is going to be equal to 500 kilograms times 9.81 meters per second squared times 10 meters all over, I think, 2,379 watts. And if we plug that in, we should get 17.5 seconds. Oh, right, that's it. There's some more sense. There we go, 17.5 seconds. So I believe the answer is. It is. And if we go to the next page, we see everything that we did here. Okay, I had remembered the number quite slightly wrong. That's okay. As you see here, they didn't actually need specific gravity. You're going to get extra information that you don't need. Remember that. So, with that, I hope this helps you, and I will see all of you next time. Bye-bye.